Today's topic is building off our Pythagorean theorem from yesterday. When we say we're applying, that just means we're doing word problems today. You can use April 23rd for your notes. And this is what your packet would look like. I think it's just one sheet double-sided. All right, let's look at example number 1. It says a guy wire is attached to a point 22 meters above the ground on a telephone pole that is perpendicular to the ground. So I drew a triangle, so I'm going to have you draw that first, but the telephone pole is standing perpendicular to the ground. So this left side would be where my telephone pole is. The wire is anchored to the ground at a point 9 meters away from the base of the pole. So if this is the base of my pole, over here on the right is where it's anchored. Find the lengths of the guy wire round to the nearest hundredths. So let me put some dimensions on my triangle. So the wire is attached 22 meters above the ground on the telephone pole. So the left side is 22. And it's anchored at a point that's 9 meters from the base of the pole. So our dimension of 9 is here at the bottom. And the guy wire is attached from the top to the stake in the ground. So my hypotenuse is x. Once we have the diagram drawn, we're going to use the Pythagorean theorem. So my legs are 9 and 22, and our missing side, the hypotenuse, is equal on the right-hand side, x squared. And if you want to use c, you can. I'm going to go ahead and square my 9 and my 22, and then I'm going to combine my like terms. We're going to take the square root of 565. Now, with an applied problem, normally I would tell you to simplify this so we had radical answers, but in the context of the problem, and it's also saying round to the nearest hundredths, you're actually just going to put this into the calculator and give me a decimal. And now I'm going to round it to 2 decimal places, and it's 23.77 meters. In example number 2, we have a ladder that's placed 2.5 feet from the foot of a wall. Remember, the ladder can't be flat against the wall or it'll fall back and you'll crack your nugget. The top of the ladder reaches a point 16.7 feet above the ground. Find the length of the ladder. So let's draw our diagram and label it. So the base is 2.5 feet from the wall, and the ladder will reach a point that is 16.7 feet above the ground. So the length of the ladder is the hypotenuse, x. So we're going to go ahead and sub in. Again, I have 2 legs, 2.5 and 16.7. My hypotenuse is missing. When I square both values, I still have decimals, but I'm going to add my like terms. And again, this is an applied problem, so we're going to go ahead and square root both sides, and then we're going to take the answer as a decimal. They did not specify how to round this problem, but I know it's not going to round to 17 and look like it's exact, so I'm going to at least give it a tenths place and say that it's 16.9 feet. In example number 3, we have a baseball diamond that's in the shape of a square, 90 feet on each side. So what I've done is I've drawn the square to represent our baseball diamond, and I've labeled home plate, first, second, and third bases. They want us to approximate to the nearest tenth of a foot the distance from home to second, so going directly across. So first, the side length, they said, is 90. And this is the distance I'm looking to calculate. So let's continue to label. We need at least 2 sides to use Pythagorean theorem. Since this is a square, I know that the other side here on my triangle is also 90. And then I'm looking for the purple distance, which is x. So again, I'm looking for my hypotenuse. So I can go ahead and sub in 90 for both A and B. So we're going to have 8100 and 8100. And when I combine those, I have 16,200. We're going to square root both sides. There's what the calculator gave me. The directions say round to the nearest tenth. So the 7 tells me what to do, and they want me to round up to 0.3. So it's 127.3 feet from home to second base. For our last example, it says that we have an isosceles triangle. That means I have two sides that are equal. Each of the equal sides measures 29 inches. So I've drawn an isosceles triangle and I've labeled those two equal sides. The altitude is drawn to the base. So from the vertex at the top, this is my vertex angle, straight down. There's my altitude, and it is 21 inches. So we'll put that on the diagram. They want us to find the length of the base. So this entire length is x, but looking at the diagram on the left and the right, I have two identical right triangles. So what I really want to find is possibly the left side or the right side base only. So that's what I'm going to do. We're going to use Pythagorean theorem to find a missing leg. Now this time I have one of my legs missing. It can be either A or B. A leg is 21 and the hypotenuse is 29. So if I square those and then subtract 441, I get a squared equals 400. I do recognize this as a perfect square. So if I square root both sides, I get the value of a to be 20. Even though that's a correct answer, I'm confident I did not really answer the question. The length of the base is actually twice my answer. So the value of x is really 40 units or inches. For part B, they want us to find the area of the triangle. So I've included 40 now as my complete base. Area of a triangle is simply 1/2 times base times height. So we're going to plug in 40 for our base and 21 for our height. And when I calculate this, I get the area to be 420. I put units squared, but it really should be inches squared. This is the homework for today. This is number 112. There's only 6 word problems. Please make sure that you draw a picture if it's not already there and that you show me all work, and then submit your assignment as soon as you've completed it. If you have any questions while you go through your assignment, please don't be afraid to contact me, and make sure you submit your assignment as a PDF. Thank you. Have a great day.